Okay, finish. Okay, today we are going to learn about graphics system on WebGL. It is about raster, graphics pipeline architecture, vertex, pixel fragment, and also shader. Okay, we start with a raster graphic. Is there anyone in this class can help me to explain what is the difference between raster graphics and vector? Is there anyone knows the difference? Maybe you can open your mic and explain to me. Hello, are you still there, guys?
Can you please repeat the question?
Yeah. Who's that?
Siska just asked, what is the difference between raster and vector? Raster and vector image or graphics. Any thought?
My name is Evelyn. I want to give my opinion about the difference between raster and vector. Is that it?
Yeah.
If we zoom in raster, it will be seen as a group of pixels. Meanwhile, if vector, there's no pixels, so it's better if we use for designing detailed graphics to use the pixeled one when we used to create something like a logo or something like designing poster or something. We use vector.
Okay. Is it VK or who is?
It's Evelyn.
Evelyn.
Oh, okay, Evelyn. I'm so sorry. I cannot see you here from here. Okay, yeah. Okay, it's okay. That's a good point, Evelyn. Uh, yeah. Is there anyone else want to give their opinion about the difference between raster graphics and vector?
Sorry, ma'am.
Evelyn, yeah, yeah.
My name is Patrick. I think the difference between raster graphics and vector is raster graphics store each information for each pixel.
Okay.
The vector stores it as a series of mathematical curves. So
Okay.
when we zoom, still will decrease clear because we zoom tiap pixelnya tuh kayak jenderet lagi gitu, Bu. Susah. Kalau misalnya raster kan pixelnya ya cuma satu terus digedein gitu jadi pecah-pecah.
Okay. Thank you very much. That's great. Okay. Yeah. Okay, wait a minute. I think I'm going to stop share. My connection is not stable, so I cannot hear your voice clearly here. Maybe because of my resolution. So I'm trying to make my resolution lower.
Gary, I just saw you typed a message on the free chats. Maybe instead writing your chat message there, you can put it on online class on scheduled channel. Right? Okay. Over here, Gary.
Okay. I cannot find the setting to set
You need to
the
choose the screen first, and then you pick the resolution and frame rate on the bottom of the window.
the button. Share your screen, yeah.
You can choose 720 and 15 FPS. I think is good enough.
Do you mean the my monitor resolution?
No, the stream quality, the stream resolution that you would like to deliver to the channel.
I cannot find the menu to set that. In the
Oh,
top
really?
cues. No.
Or maybe I can help with the screen share.
Oh, okay. Yeah. Maybe you can help for the screen sharing, Mr. Hazik.
Hopefully, this will make your voice clear. And for any of you that prefer to not watch my stream, you can also open a browser and type classpoint.app/join. I will put it on online class on schedule channel. But it only provides 25 seats. So the first 25 people joining will be able to see the slides. But for the rest, please just use the stream. The code is 3434250. Please have a check on the online class schedule. Online class on schedule. Click on that link and then put your code over here and type your nickname. Once you join the last point, you can see the current slides that Busiska will be presenting.
Yeah. Thank you very much for the explanation, Mr. Hazik. Okay, the present code, I post the present code in the online class on schedule channel, so you can present there by using the present code. In my view right now, I still loading to show the PowerPoint that you show in your computer. I don't know, maybe my internet connection or okay.
I think it's very normal, because in this afternoon everyone is using the internet, so the connection would be very unstable for most of people. No worry, quite usual.
Okay. Yeah, I think. Okay, I have
You can
opened
just
the
stop
class.
the stream if you want.
Yeah, yeah, I have opened the class point, sir. And would you like to help me to the code about the code in the class point? I have opened the class point.
Oh, Dewanga, you cannot hear anything there, really. Do you think that our server need to boost it to be boosted? Oh, if I'm not mistaken, the server was boosted by 3 students already. Should be fine for the quality, I think. Oh, great. Okay, so the problem is in Busiska. Just wait for a bit. Busiska, do you think you need to restart your modem or your router? Okay, it seems Busiska already left the conversation. Is she? Did she? Oh, she still here. Busiska, copy. Ah, yeah, changing server location might help. Uh, any recommendations, Shafiq? So let me go to the server settings. Mm, oh, Busiska use browser. Maybe, yeah, we recommend you to install the application, but I think it affects the performance. By the way, Shafiq, do you know how to change the server? Gosh, server location should be in server settings, right?
Maybe you can
I
right
cannot
click
find
on the
this.
live class channel, sir, and then you can
Oh,
change from there.
where's Gare? In which look in
Right click on the
where?
channel, sir.
Oh no,
Edit channel.
edit channel. I thought it's okay. Let me check the video quality, the region override. So I'm just gonna pick. What is your suggestion? Hong Kong, Japan, Singapore?
I think
Let me
Hong Kong is more stable.
Hong Kong is more stable.
Yeah.
Let Hong Kong. Yeah, it's already in Hong Kong now. Okay, meanwhile we are waiting for Busiska. How's about playing Genshin? Let's go.
Let's go, sir.
Let's play Tetris. Let's play Tetris.
Let's do that.
Let's play Tetris, sir.
Maybe you can,
Really.
or maybe we can create a new category, guys, in the server, just for online gathering playing games.
Yes, I think that's a good idea, sir.
That's a good idea, maybe.
What games do you want to play in addition to Genshin? You can just tell me in the free chats. Maybe I can create the channels for you, and you can teach me how to play. So far, I only play Genshin in regular basis. I'm afraid that we cannot play Tetris in multiplayer mode, Gare.
Actually, we can, sir.
Actually, we can.
Really?
We use Tether.io. We can create account on that website and play from browser.
That's good idea. Just please teach me later. Okay, not
Okay.
not for this time. Okay. Meanwhile, Busiska install the application. Maybe I will move out from the PowerPoint slide for a bit. Let's go to the browser, and I would need you to follow my instructions. Please check on, so it will not be available on the class point. So you will need to go to my stream windows to see what I'm doing. We will go to, I think, let me see. Do we have, oh, maybe I need to go to classroom.github.com. And then I would need you to click on an assignment link. I will put it on the. No, it's not light mode. If this one is dark mode.
Okay, sir, I success to install the Discord in my desktop, so I can hear your voice now clearly. Thank you very much, guys, for your
Okay,
help.
great.
Okay.
Awesome solution from the students. Thank you very much, guys. So let me finish this first, Bu Siska, before we move back to the presentation slides.
Thank you very much.
Oh, you said the GitHub. If I don't know how to change this to dark mode. I do not even know. It's so slow. Why? There is something unusual. I'm not quite sure what's happening. It's too slow. Is it done? Is it down? Oh, okay, Eve, thanks. I've never thought that that would be okay. Oh, I sync it with the system. So I set it fairly, okay? So I will use the dark mode during the night. I'm just gonna make it fair. No offense for the dark mode fans. I'm so sorry. Okay. Okay, for your pleasure. I'm just gonna choose this then. Single theme. let me please your eyes. Okay, this one I think your most favorite.
The white one, I think it's better than the black one. But all of you really agree with this one, this black one.
We save the environment, boo. It's
Oh,
for the sake of
bandwidth.
avoiding the global warming.
Oh,
We
global
save
warming.
the energy. Yeah,
Oh, okay.
said
Okay.
someone. Oh no, this is so slow. So maybe we can go back to slide, but you can continue. Oh no, it's just connected. Let me continue first. Here we go. Where's yours, guys? I think class E, right? This one. Okay, still slow. Let's go back to the slide. Go ahead, Bu Siska.
Okay, maybe you can back to the previous. Okay, thank you very much, Mr. Hazik. Okay, guys, like what you said before, you said that the raster graphics is generated as an array of pixels. That's right. There is so many pixel here, and the quality of the image in the picture in this, the quality of the picture here is depends on the pixel, the resolution. That's it. That's in raster graphics. This image here in the left side, we can call it pixelation. If we use raster graphics and we try to zoom in, the picture is will become not clearly to be seen by us. That's we call this one is pixelation. It's caused by the pixelation because the resolution is not high, so the image will show like this, will be shown like this in the left side image. And then the factor use a mathematics formula to generate the image, the curves, the lines, etc. that make up the image is calculated by mathematical formula, and when we try to zoom in the image, the computer will calculate again the lines, the curve by using the mathematics formula. So it will not be like this image in the left side, this one. The image will be still good in Outlook. It is in the high size, something like that. After we zoom in the image, something. Yeah, the factor use the mathematical formula to generate the image. That's it. Okay, Miss, can continue to the next.
Okay.
Okay. Then how our graphics form? There are two approach here, as you can see in this slide. The first is physics approach and the second is practical approach. In the physics approach, there are two methods, ray tracing and radiosity. The ray tracing here is where the calculation model and graphical generation follow the light rays from the center of the projection until they are observed by the object or terminate at infinity. For the example, when we are enter our room and we turn off the light, we cannot see anything around us. Is that right? yeah, when we turn off the light, we cannot see anything around us. So when we try to turn on, I mean, before turn off, yeah, when we enter the room and we turn off the light, we cannot see anything around us because the light is off. But when we try to turn on the light, we can see many objects around us. It is because of the light rays. The light will bounce to each object around us, and it will be captured by our retina, so we can see what is around us, any object around us. That's ray tracing. It's different with radiosity. The radiosity is energy-based approach to objects. Each object, every object has energy. And for the example is the sun, the star, they can shine because they have an energy. That's why our object in our surrounding can be seen by us not only because of the light but also because of the energy in each object. This physics approach are ideal. Why? Because this physics approach can simulate the the real environment in the computer graphics visualization, but it needs high computation. The computational is very expensive, and it's also make our computer or our device very slow. That's why there is not many there are not many device that is use this approach. And then there is a practical approach. This practical approach are processed one at a time. The object in this practical approach are processed one at a time in the order in which they are generated by the application. This approach only considers local lighting. So the environment will be generated, the object will be generated when it's shown in the application. They will not generate all of the environment for the application running is not like the ray tracing or radiosity. And then the architecture pipeline will be explained in the next slide. And this approach is our focus in this course. Our course today will be focused in this practical approach. Okay, maybe we can continue to the next slide. This is the basic graphic system. We start from the input controls. When we try to interact with a computer device or any device, we need input control. Now, for the example, input control here is keyboard, mouse, pen tablet, or maybe lip motion controller, or maybe Oculus Rift controller. We can interact with the computer by using this controller. This controller sends instruction to the central processor or CPU and then store the instruction in RAM before it is executed by the computer. When the instruction is executed, it will send to the GPU to give a response for what is given from input control. This is the GPU. The input control send the instruction. The central processing unit here store the instruction in RAM, and then when the instruction is executed, the computer will send the response to the GPU, and GPU try to visualize the response in the monitor by by using the frame buffer. Here the frame buffer will generate the output display here. The graphics are rendered in the frame buffer. Okay, there is a question. Where is the local lighting? Local lighting. Where is? When we generate environment in the virtual, when we generate a virtual environment, for example, when we use Unity, there is so many kind of lighting, isn't it? When we use a local lighting, it means that the object that will be rendered is not is based on the size of our local. Okay, maybe I'm going to explain in Indonesia in bahasa. Ya, jadi maksudnya local lighting itu kalau misalnya kita buat environment ya di Unity atau apa virtual environment, di situ kan ada banyak ya jenis-jenis lighting dan seterusnya. Nah, local lighting itu ibaratnya kita ada di ruang gelap, terus kita punya senter atau punya lilin. Maka dia akan menyinari sekitar itu saja karena kapasitas intensitas the intensity of the light, the sinar itu, jadi intensitas cahayanya itu tidak sebesar ketika kita seperti matahari mungkin atau apa dan seterusnya. Jadi dia hanya menyinari yang ada di sekitar situ. Ibaratnya kamera hanya bisa menangkap sesuai apa yang ada di dalam cakupannya. Jadi tidak semua objek dalam satu waktu ya default light in Blender. Ya, something like that. Jadi tidak semua dalam satu waktu semua objek di dalam dunia virtual itu di-render, tidak semuanya langsung di-render, tapi objek yang tertangkap kamera, objek yang masih masuk ke dalam cakupan local lighting itu saja yang di-generate. Jadi tidak semuanya. Yeah. Something like that. Or maybe Mr. Hazik can help me to give more detail, or maybe I'm wrong. Okay. Thank you.
Evelyn just presented a very brilliant question, so I believe that she reflected on from the previous slides,
Yeah,
saying
what
that in this practical approach we only considers about the local lighting instead of the global lights. I may say that in the ray tracing or radio city approach, we will need to consider all the light, which means not only from the light sources, but also the rays, the ray lights that is bounced from the surrounding, maybe before arriving at our retina. Some the light rays that come from some objects will need to travel to another object, maybe to the wall or to the other surrounding objects, and then bounced and then go to our eyes, into our retina. When we want to consider about the global lighting instead of local lighting, then it means we need to calculate the whole light rays, incoming light rays from any directions to the retina. Okay, so to the object and to the retina. So it's very complex calculation and it's very expensive. However, in our practical approach, just like I think Gary said, ambient light is one of the local lighting that we will utilize or we will calculate in our practical approach. Another lighting would be point light and then spotlight, etc. But the point is basically when we calculate that light, we use the perspective. We use the perspective from the object, slowly from the object. So we will use a very simple formula. So we do not care about where that light comes from, whether it bounces from the wall or from other objects. So we just use some very simple formula from the perspective of the object that we would like to see, that the users would like to perceive. So that's the point. Do you get the idea, guys? We may continue the discussion if you're still confused.
Okay.
All right, good. Then let me go back to the next slide. Go ahead, Buziska. You may continue.
Okay, thank you very much, Mr. for the explanation. Okay, this is the modern graphics library. In the modern graphics library, performance is achieved by the GPU, not CPU. CPU only receives the instruction and process it and respond the instruction into the monitor, into the output device by using this GPU. GPU will show what the instruction execute in this CPU. The GPU will process anything that related to the visualization that is sent by the CPU. And then the next, CPU is controlled through programs called shaders. In GPU, there is a program that's called shaders. We will learn about these shaders. There is vertex shaders or maybe fragment shaders later. We will learn about these shaders later. Okay. Then next, the job of the application like JavaScript is to send data to the GPU. JavaScript here is a programming language that it will be used to define the data that will describe the object that we are going to draw in the monitor, something like that, such as the vertex, the coordinate of the vertex, the position, the color, etc. We will define it in this JavaScript. The animation, maybe we will define it in this JavaScript. And then this JavaScript is send the data to the GPU, and then GPU is the one who does the whole rendering process. The GPU will do the rendering process and show the graphics like what the JavaScript like the instruction in the JavaScript. Okay, maybe next.
Yeah. In
Yes.
brief, basically CPU is responsible for preparing and managing and transforming or manipulating the data, and GPU will be responsible for drawing the data. So that's in short.
Okay, thank you very much, Mr. Okay, this is some of graphics library. There is GLES embedded system. This library is used to develop embedded system when we use a device such as a Raspberry, or we are going to develop a mobile application. We can use this OpenGLES embedded system. This OpenGLES version 1.0 is a simplification of OpenGL 2.1, and then OpenGLES version 2.0 is a simplification of OpenGL 3.1. This OpenGL 3.1 adopts shader based. Okay, this is the WebGL. What we are going to use in this course, we use this JavaScript and also HTML to implement the OpenGLES version 2.0. And then the last year, OpenGL 4.1 and 4.2. You can search in the Google, in the internet, for the newest version of this OpenGL. Yeah, because we do not update this. There are additional geometry here, isolation and shader calculation technique. This 4.1 and 4.2 version.
Especially the geometry and tessellation. These two techniques are only covered in OpenGL, the newest version of OpenGL. In the previous version, just like 2.1 or 3.1, there is no geometry, there is no tessellation. It means like if we want to draw a cube or to draw a sphere, OpenGL will just provide the function or the method for you to draw. But in 3.1, OpenGL 2.1, we will need to define the geometry by ourselves through several primitives and tessellation as well. So we will not cover this in our course. So we will just use the primitives, and through some shaders calculation techniques specifically that come specifically from 3.1 from the OpenGL 3.1, because this 3.1 is equal as its simplification version is OpenGL ES embedded system version 2.0, and this OpenGL ES version 2.0 is equal to, we can say that, equal to WebGL 1.0. WebGL is basically the API JavaScript. So if you write a code in JavaScript and you want to access some mechanism, some techniques to draw, just like in OpenGL ES 2.0, then WebGL is the answer for you that you can use. By the way, if you Google these keywords, the WebGL, you may find that currently WebGL is undergoing the development of WebGL 2.0, which is, I think, yet the next version of OpenGL ES, the 3.0 OpenGL ES, but I'm not quite sure whether we can cover that. But if it's possible throughout this course, maybe in the second half of our semester, we will try to learn a few things that is available in WebGL 2.0 but not available in 1.0. Hopefully, let's see.
Okay, thank you very much. The next is computer graphics app execution for execution process through WebGL. The execution involves web servers and web servers. To execute the WebGL application, we do not need to install any other program. We just need web browser to access it. When we open the web browser and we type the URL here to request to the web server, the URL is sending a request to the web server, and the web server will send the response as a web page by using the HTML tag, HTML language, and then web browser will be will be translate the HTML and then show it in the web browser. But before it's shown in the web browser, there is a JavaScript engine, JS engine, and then the JS engine will read the instruction what are going to draw there in the canvas. What about the animation, the vertex position, the color, etc. And this is also GLSS. GLSL. We are going to learn this. Also, we are going to learn this later. This is the language for graphics to make like a material for the material texture, etc. And then here we have a frame buffer, like what I explained before, and then this frame buffer will show the object in the HTML5 canvas. So here we start from the web browser. Web browser will send a request by using this URL to the web server. Web server will respond by sending the page by using the HTML syntax, and then web browser will try to translate the HTML syntax and try to translate the instruction in the JavaScript by using the JavaScript engine. JavaScript engine will call the GLSL. Maybe if there is any something like a texture or maybe material that is used in the object, and then in the frame buffer the object, the image, the picture will be generated here and then shown in the HTML canvas. The HTML5 canvas here is a area in the HTML page, is a area that we define in the HTML page. This area can be used to draw the WebGL object, the object that we use in WebGL. The HTML canvas is the area in HTML page that can be used to draw by using the WebGL library, something like that.
Yeah. Please do remember, guys, that we specifically use HTML5. So we cannot use the previous version. HTML4 will not work with the WebGL. So, but I think that's really not a problem, because the modern browsers nowadays, all of them using HTML5. And GLSL. GLSL stands for Graphic Library Shading Language. Maybe I can also put it on the chat. I just realized that we have a David Jajetin in the audience. Who is this? Okay, Bu
So
Siska, you can continue.
okay. Okay. This is yeah, the execution in the process, the app execution process for WebGL start in the HTML page. First, here we need to describe the page, the HTML. We will define the canvas, the area, the width, and the height of the canvas, and then we also will define the supporting JavaScript file. If we write the JavaScript code in the different file, we need to add script and the source name of the file and access it in this HTML file. And then the second here is define shaders. Yeah, we will use GLSL like what Mr. Haji before. Yeah, this we will define the shader. We can use a different file GLSL. I mean, then the third here is computing or specifying data. Yeah, the JavaScript here we will describe the vertex coordinate position of vertex, color of each vertex by using this JavaScript, and then the instruction from the JavaScript code will be computed in this third process, and then the fourth process is sending data to the GPU. The GPU will receive the data about the position, the vertex, the color, etc. And then the five, the JavaScript, the GPU will be render the data. Then the five.
Okay. I'm sorry. By the way, I'm so sorry. We haven't yet translate this one. We will revise the document later.
Okay, the next is this is the practical pipeline architecture of computer graphics. It starts from the vertex. Yeah? We start from the vertex. The vertex has its position, has its color, etc. The vertex processing will collect those data and send it into this process, the clipping and primitive assembly. Clipping means each vertex will be put in their position, and then the camera will capture the position of the vertex, and the vertex that is not captured by camera will be clipped out, something like that. And the primitive assembly means this process we will collect the primitive shape of the object, such as line, the vertex itself, and then maybe there is polygon or any primitive shapes that make up the yang menyusun objek tersebut. And then in the rasterization, we continue to the rasterization process, and in the fragment processing, we are going to color the fragment. Each vertex is a pixel in the object, and then it will be shown in this monitor.
Yeah. It seems everybody, maybe I'm afraid that everybody's get bored. Bu Siska,
Yeah.
I think we need to get the
Okay.
hands-on by
Okay,
now.
guys.
Okay, so before we continue to the next slide, I think we will just put this one into practice. So let's try to
Read the HTML.
code the applications, getting started with the WebGL application, the web application. Before doing that, we will need you to prepare something. Let me see here. Yeah, it's ready. Please click the link that I've just pasted on the online class on schedule channel over there. Or maybe I'm just gonna also put the link on the Class E channel in case that somebody are okay. Once you put the link on the browser, please accept the assignment. Okay, click accept the assignment and then it's done. You may need to give me a moment. You need to have a check on your email box. Otherwise, let me check to refresh this page. Yes, here we go. You need to refresh the page and then you can open the repository, this repository directly on your Visual Studio Code, or you can do the manual cloning from the GitHub website. Oh, finally, dark theme. Thanks God. Okay, you can clone the repository or download the zip file. It's okay to your computer. And after this, let's start get our hands dirty. Maybe you would like to try share your screen, Bu Siska. Perhaps now is fine since you have installed the desktop version of the Discord.
Okay, sir. Okay.
Please stop streaming.
Okay. I also have installed the GitHub desktop here for what to help me to GitHub to help me to clone the data. Here you can use a command line interface CLE, but here I use the graphical graphic here graphical user interface, so we don't need to learn about the any other language. Maybe you will confuse about the language such as ls, maybe make dir to create a new folder, etc. Here wait a minute, I don't know, close stream. Okay, in this GitHub, I have if you are going to add a new repository, you can click file new repository here, and then you can type the name of the repository such as class E CG21, and then this is description. If there is no description, you can keep this description blank, and then you can search for the local path. Here you can choose where you will store the file. I store the file in this folder, graphical computer tm2 script class E. Here I select this folder, and then git ignore etc., and then we are going to create the repository. This is how to create the repository, but sorry, we are not going to create the repository, but we are going to clone. I'm so sorry. Yeah. To add the clone the repository, we can use this feature file clone repository, and then we can choose the local path here. Choose the I put in the same path as before. WebGL, in this class E, select. Okay, I'm going to delete first. Okay, I select this class E. Okay, this one in this class E, I select the folder. And then the next is we are going to type the URL. We copy paste the URL from the GitHub cloning repository. If you see, sorry, I'm going to share I don't know how to share the entire screen here, so I need to share one by one the screen.
You should choose the screen tab. Normally, by default, it will direct you in the beginning, direct you to the application sharing. Top of the screen share panel or the window or the pop-up window.
Oh, yeah, screen. Yeah. Okay, sir. Okay. I right now I show this screen, and then I'm going to show this GitHub. This is our repository here. We need to clone this repository by click this right green button here and then we can copy this one. Copy it. How to install the GitHub desktop? You can use this menu, click this menu, or you can use command line, CLE, command line interface. But you need to install some some program to make the command line interface can run the GitHub command. But if you don't want to use that command line interface, you can use the GitHub by using the GitHub desktop here. You can click here and then you can download the application. After it, you can install the application, so you now have the application like what I have here. That's GitHub desktop. After we have the GitHub desktop, we are going to copy paste. We are going to clone. We are going to clone the repository here. We need to copy the URL, the HTTPS URL here. We copy it and then we open our repository, clone a repository. We can choose here file. In the laptop menu there is file. We can add local repository or maybe clone repository. We are going to clone the repository from the GitHub that we have in the class ECG 2021 here. We can copy paste the repo, full repo here, URL or GitHub username and repository. And then this is the local path where we are going to store the file in our local computer. And then press clone, click clone to start cloning. This is the process. Okay, this is the folder. Current main, this is the folder. And when we open the folder here, class E, here we create a new folder named learn-webgl. We can see the time here, 2:04 p.m. Yeah, this is the file that we had download. So now we can begin to open the Visual Studio Code. It's okay, it's up to you if you are going to use the desktop GitHub application or maybe you are going to use command line interface. It's okay. Yeah, but for me, it's easy for me to use this desktop GitHub for me. It's okay if you are going to use the command line interface. Okay, and then we are going to this folder. And then we are going to open the folder that we have downloaded before. This folder, we can search the location of the folder. This one, class E, this is the folder. Okay, we are going to add this. And do you trust the authors? We can press yes. And this is the folder that we show in this workspace, in this Visual Studio Code workspace. That's it. So the first we are going to start to create the HTML page so our WebGL can run, and we also will add a new JavaScript file to create the instruction to draw something in our HTML page. Before we start to create the file, you can also use this extension live share to share the code. So yeah, so anyone with the share link can access the code online and they can view the code online real time. When I edit the code, the real time code will change. You can use this one, live share. You need to install it first by using the extension in the left panel here. To use the live share, you can click share, and then the system will starting, and then you can make read only, and then here you can this is to stop the collaboration session, and this is the contact who join this live share session online. Now to invite the participants, you can copy the link here, you can click, and then this is there is a notification here, invite link copy to clipboard. So now I'm going to paste the link in this online class, so you can join my live share in Visual Studio Code, so we can code together. We can show how I code this clearly. Okay, that's okay. We can always accept anonymous. Okay, thank you. Yeah, there's some guests anonymous. There's 2 participants here that join this live share, and then I'm going to continue to the adding a HTML page. We can right click here and choose new file. When we choose new file, we can type the name of the file here. I'm going to name it index.html here. Now we have a new file named index.html. And then if we use any other text editor, we need to type the HTML tag one by one. But in Visual Studio Code, there is embed that we can use to type the HTML tag for general something like this. There's embed. How to use embed? We can use this tanda seru, image abbreviation, and then we click it, so the default syntax from HTML tag will be typed automatically here, and then we only can change a little anything here. We can change the title, or maybe we can add some more code here, or etc. This is our first HTML page. Hello. We can use paragraph, maybe. I think all of you is ever learned about the HTML language, and then to run this HTML page here, you can use the live server. This is the extension in Visual Studio Code to make a local server in your computer. Not only live server, you can also use Node.js or maybe XAMPP to run your web application. But in this case, in our course, in this Visual Studio, we are going to use the live server extension here. To run this web page in our local server, we need to right click here and then open with live server. So the live server will run the Microsoft Edge here, and shows the page that we are carried before. This is the first page that we. Is there any question from here? If there is no question, I'm going to create the canvas. What we need to draw an object in this web page, we need a canvas. Like in our real world, when we are going to draw something, we need a paper maybe. Yeah, we need a paper. We need a media to draw, such as a paper, maybe what is that? Kain ya, kain bisa dijadikan media untuk menggambar. Yeah, something like that. Or maybe tembok, wall. You can draw in a wall. Murals, something like that. Murals. Nah, in this, what are you going, Nabil? In this WebGL, we are going to use what is that? Canvas. Yeah, we will use the canvas tag here, and the canvas here is an area in this web page. In this web page, this area that will be used by us to draw any object by using the WebGL library. This is the canvas. The canvas is the area in the web page that will be used to what? Nabil, what are you going? Nabil, I don't know. Nabil can edit. Yeah. Yeah, read only. I don't know why you can edit this code. Okay, it's okay. Yeah. Okay. For the first, we are going to create the canvas. The canvas is the media for us to draw. Not only, yeah, we can draw. Yeah, here I don't illustrate. Yeah, we can draw anything in the paper, maybe, or maybe in the what is that? Oh, in the wall, like murals. And in the web page, we can draw in the canvas. We call it canvas. This is the area that we are going to draw something in it. Yeah. For the first, we are going to define the width and height of the canvas. Maybe we are going to use 750, and then the height maybe 500. And we also can give the ID of the canvas, so we can access the canvas based on its ID. So I'm going to create the ID, maybe my canvas as the ID. We can, yeah, give the canvas ID. This is my canvas. When we show this web page, there is nothing. Yeah, if you see here, there is nothing. But to make the canvas, so I'm going to make a difference between the canvas and the web page. I'm going to make a border here. Jadi saya ingin membuat perbedaan gitu ya, mana bagian canvas, where is the canvas area and web page area. I'm going to create a border here. Maybe I'm going border here is solid, maybe red or black. Okay, something like this. So we can see, as we can see here, there is a line, there is ada kotak gitu ya, ada area, there is a border in this area. That means in this area we can draw anything by using the WebGL library. This is the area of the canvas. We divide the web page area and the canvas area by using this border. Jadi kita memisahkan area canvas kita dengan area halaman web itu, halaman web tadi, dengan menggunakan border ini. Sorry. Yeah. This is the first HTML page that we have. As we can see in the slide, the first thing that we are going to do to create the web application by using WebGL library is describe this HTML page. And then the next, we are going to define shaders, but we are going to learn about shaders later, about the GLSL later. But right now I'm going to create the JavaScript to specify the vertex, the coordinate of the vertex, and then maybe the color of the vertex. We are going to do a simple code to create a one vertex, one satu titik, yeah, one node in the canvas. So the next here, I'm going to create a new file and name it maybe main.js. And here we can type the code here, or you can make a function in the main.js. We can use a function and we name the function as main. Okay, to integrate this main.js file and this index.html file, what we need here is introduce the main.js to HTML file. How to introduce the file? We use script tag here. Jadi kita akan mengenalkan file main.js ini di halaman HTML ini. Jadi cara perkenalannya kita menggunakan tag script. In this script tag, we use source and we can type the location or maybe the name of the file. Here the name is main.js. So the index HTML has no. Ya, jadi dia sudah tahu about the main.js. And then to check that this index.html connect to this main.js, we can try to console. We can write line. Maybe we are going to type hello world. Console log hello. And to test it, we can open our web browser. We can refresh maybe, or we can open and inspect the element. There's console here. We can see what is right in the console. Forget the syntax. Okay, this is the output. Yeah, this one. Okay. Thing here. Wait. I'm going to check. Maybe there is something missing. Main.js script source.
The
Oh,
problem
I
is,
know the
yeah,
ID.
you know that.
Yeah, because here I just yeah, console log. No, I just there's not related with this ID.
No, it's not related to that. The problem is because our program, they know the source of the JavaScript, but
Yeah.
it hasn't yet loaded the JavaScript into its body.
So I need to stop the live server and then rerun again.
No. That's not the problem. The live server will sync our progress in the code. So the solution is by putting the onload
Oh
Uh,
yeah, I think in
inside
the
the body
body.
tag.
Okay,
Yeah.
okay. Yeah, okay. I forget about that. Okay. Yeah. As we know, to render this web page, the browser will translate this HTML tag and will render what is written in this body. But to have this body to connect this body with the main.js file, we not only need to introduce this main.js file here, but we need to what is that? We need to call the function that we define in this main.js. Jadi tidak hanya mengenalkan di sini main.js-nya, tapi kita juga harus memanggil fungsinya.
Correct.
We need
Yes.
to call the function in this body. So when
Exactly.
when the web browser is execute, when the web browser translate this body page into the web browser, the HTML page, it will load the function in this main.js and execute any related code in this view. So what I need is onload main something.
Yeah. I think I said the mistake statement, the wrong statement. I say that before you put the onload equal to, and then within the quote main, and then the parenthesis. Actually, the HTML has already loaded the strings of the JavaScript into its body, but we haven't yet called the function. We need to execute the code within the main function by calling that main function after onload event triggered. And this is the
Okay.
way just shown by Busiska. Thank you, Bu.
Okay, yeah. There is someone here who said that uh, they say that we can use the JavaScript and then with the HTML as one file. We can copy paste the JavaScript code here in the HTML body, so it will load the instruction. But we prefer use a different file so we can what is that? We can manage our code clearly, so we can understand what is the function that is used to shows any graphics or anything in our web page like that.
Yeah, we prefer to work in a modular. So
Yeah,
if we later need to extend functions, we need to add more functionality, then our HTML will not really kind of cumbersome to overwhelmed. So the best way is by separating the codes into its dedicated JavaScript files.
yeah, that's right. I think our student had learned about object-oriented programming. We divide the main class with any other class, any other object based on its functionality. So we can access it modularly and we can manage our code without tanpa pusing gitu ya memanage kode kita. Kalau sudah ada fungsi,
With no headache, yes.
yeah. This is
Now let's prove it, Bu. Let's prove it whether it's work or not. We need to check the browser now.
yeah, this one, sir. It
Okay,
works.
good. Awesome. It works. We can see that the hello over here.
Hello. That's a sound. Okay, for the next step here, we are going to create the what is that? Vertex shader and then fragment shader. But before we create the fragment and vertex shader, we need to create the vertex and we need to define, not create. We need to define the vertex and the position or maybe the point size of the vertex so the main.js can execute it and can have the location or position vertex, something like that. Yeah. For the first here, no. Before we define the vertex, I think we are going to access the canvas. Yeah, before we draw, in our canvas, we need to access canvas first. Like what we do in our real world, before we are going to draw in a paper, we need to have a paper first. We need to choose the paper that we are going to draw. This is the process how to choose the paper. We need to access the paper, or in here we call it canvas, by using document get element by ID. One, and we can type the ID of the canvas that we write before. Here the ID is my canvas. We type here this one. This code, from this code, we can access our canvas. So now we have a canvas, we have a media to draw, we have a paper to draw, like that. This code is used to access our canvas. Before we define the vertex, the color, the size of the vertex, we need to have to access the media for drawing, the media to draw. In this case, we need to access the canvas. Yeah, in our real world, we need to have a paper before we can draw or write on it. We can choose the paper, but based on its ID here. Yeah, we choose the canvas based on the ID, and then before we draw, we also need tools to draw. Yeah. Jadi kita butuh alat untuk menggambar. And then how to define the tools to draw? Here we can create a context. Like we can create a context. We will use the library WebGL. We can define new variables, name context. Here, canvas dot get context. As you can see here in my here, there is a HTML canvas element. This get context can be used to rendering context 2D setting if you use 2D, and this one is identifier of the type of canvas to create. This is the identifier of the type of canvas to create. In the Internet Explorer 9 and Internet Explorer 10 support only 2D context using canvas get context. Yeah, in Internet Explorer, it's only support 2D context by using this canvas. Preview also support 3D WebGL using the canvas get context experimental WebGL. In the Internet Explorer 11 version, in the 11. This identifier will return an object that provides method and property for drawing and manipulating image and graphic on a canvas element in document. Yeah, this context object includes information about the color, line width, font, and other graphics matter that can be drawn. This is the tools that we are going to use to draw in our canvas. We name it, we use WebGL, so here we are going to type WebGL. Yeah, this is the parameter that will be used to define our tools to draw in our canvas. Yeah, this library is the tool that will be used to draw in our canvas. Okay, is there any question before I continue for the next? Anything? No? Okay, if there is no any question, I'm going to continue. I'm going to continue to define the vertex. Yeah, we are going to draw a vertex, one vertex in the middle of the area in the here. I'm going to draw one vertex here. And for the first, we need to define the vertex. We create a variable here, vertex shader. Good. This vertex shader has a void name, and here has a GL position. Yeah, for the position of vertex shader, we use a vector for dimension to define the position of the vertex. There is x position, this is float, x, this is y position, and z position. And the fourth parameter here is the projection. Yeah, we use homogeneous coordinate. Yeah, homogeneous coordinate. If you search in the Google, the GL position here use homogeneous coordinate. There is x, y, z position, and also y in the last parameter. The fourth parameter is y. This y parameter will be multiplied by the x, y, and z parameter. So this way is a projection. Jadi di dalam GL position ini kita mengirimkan 4 parameter, yaitu di sini x, parameter y, parameter z, dan di sini adalah projection. Projection itu ya proyeksi ya, karena kita kan mensimulasikan 3 dimensi menjadi gambar dua dimensi gitu ya di layar monitor. Jadi kita butuh proyeksi. Jadi seolah-olah membuat gambar 3 dimensi, seolah-olah membuat gambar 2 dimensi menjadi gambar 3 dimensi. Nah, nanti proyeksi ini, parameter yang terakhir ini, the fourth parameter will be multiplied with this x, y, and z. And then we are going to put the vertex in the position based on the result of this multiplication, gitu ya. Jadi kita akan meletakkan titik vertex itu berdasarkan hasil perkalian ini tadi. Jadi 1 dikali 0, 1 kali 0, itu ya. Ini adalah projection. This is the x, y, and z. This is the GL position parameter. Dia menggunakan homogeneous coordinate. You can search in the Google about the homogeneous coordinate. Okay. And then there is also GL point size. Point size here will be used to define the size of the vertex. Here we use 10 to make it more clear so you can see the point there. Yeah, we are going to use point size. Yeah, Okay, now we have defined our vertex shader. After we have the vertex shader, we are going to create the vertex shader. So the vertex shader that we are create, we will compile it into a program by using this instruction, this code. Yeah, first we are going to define a new variable named vertex shader. Yeah, to create the vertex shader, we need to create a program and compile the program. So the program will create the vertex shader. Here we use text dot create shader context vertex. You can use Google. You also can search this code in the internet, so you can get more explanation about the function of each instruction, each code in this main.js function. Then context shader source. vertex shader, and vertex here. We are going to create a source, yeah, here, the source. The source, the parameter in the shader source here, the vertex shader here, the vertex shader variable here, and then the vertex shader code for the position and the point size. After that, we are going to compile it by using the text compile shader. Vertex shader. Now we have done with this vertex shader creation. Jadi kita sudah punya vertex creation, have create the vertex shader ya, kita selesai dengan vertex shader. And then after we create the vertex shader, like what you learn from the slide here, we have two vertex processing, and then clipping, rasterization, and there is also fragment processing. We need to create fragment. We have the vertex, we have the vertex, the position of the vertex, the size of the vertex, maybe the color of the vertex will be defined in this fragment processor. Jadi ketika kita sudah punya vertex dan lokasinya, the next step is to define the color of the vertex. The color of the vertex will be defined in this fragment processing. This process, we only put the vertex in its coordinates, something like that. To have the color, we need to create the fragment processing. In the fragment processing, we will use fragment shader. For the first, we are going to create new variable here, name fragment shader code. Yeah. Use void main, and then we are use gl frag color. Frag color means fragment color. Yeah. After we create the vertex, the size of the vertex, and the position of the vertex, now we are going to color the vertex by define the fragment color. In this fragment processing, we are going to color the vertex. Jadi di tahap ini kita akan memberi warna vertex kita tadi itu. Jadi this variable is used to define the color. We use vector 4 dimensi. We use the vector full dimension here. There are 4 parameters. There are red, green, maybe, yeah, and blue. And the last parameter is alpha. Alpha is used for transparency. In PowerPoint, here there is a shape. When we add a shape here, the color of the shape is full, something like this. So we can make this shape transparent by using transparency. Yeah, transparency. Nah, to make this one transparency, we can use this transparency parameter. In WebGL, we can use this alpha parameter to set the transparency. We use 1 for the default. We can use a parameter higher than 0. If we set it 0, it means there is nothing shown in your view, in your canvas. Okay. I think istirahat sebentar ya Pak karena azan. I'm going to mute for a while because of azan. Maybe.
All right.
Yeah. Okay, I'm going to. Okay, thank you very much everyone for the for this. I have revised. Yeah, the shader sources not defined. Yeah, should I import any library? Yeah, it's shader source, not shader sources. My bad. I forget. I typed the wrong syntax. Function names shader source, shader source. The parameter is the vertex shader here, and code for the vertex function that contains the position and the size. Okay, let's continue here. In here we are going to define the fragment. Yeah, we color our text in this fragment shader. Good. So we are going to define the color of the vertex, I mean, in this variable fragment shader code. Yeah, this is the red here, green, and blue. The last parameter here, the fourth parameter, is alpha. It defines the transparency of the of the image or of the vertex. Yeah, like what I explained before in the PowerPoint, transparency like this shape ya. Jadi transparency itu seperti ini cepat. And then we can set the transparency. We can for shape here there is transparency. In PowerPoint, when the transparency is 0, the view, the color and etc. is full ya. Jadi tampilannya full transparansinya. But when we set it to 20, 30, or maybe 100, yeah, when it become 100, it will clear the fill here, the shape fill here, yeah, because it transparent, make it transparent gitu ya, transparan gitu, bisa dilihat, yeah, that's the function of this last parameter, the alpha parameter. So in this WebGL code, in this WebGL library, the transparency can be higher than 0. Jadi di WebGL ini nilai transparansi, parameter transparansi itu seharusnya lebih tinggi daripada 0. If we set this one 0, it means there is nothing, it's transparent, there is nothing to show in your canvas. But if we set it higher than 0, it will show the color, and ya dia akan menampilkan objeknya di situ sesuai dengan nilai transparansi. Nanti we are going to check it after we finish all the ya, kita akan coba-coba nanti ya setelah. Okay, after we create the after we define the fragment shader, we are going to compile the fragment shader that we defined before, like the vertex shader here. We are going to compile it by make it a source and then compile the shader. Here I will define a new variable name fragment shader. Context create program. Yeah, this create program. Yeah, create program. Oh, sorry, not create program, create shader. This is sebelum ke create program, we need to create shader first. Ya, jadi kita definisikan dulu vertex dan juga fragment. Vertex untuk titik-titiknya dan posisinya serta ukurannya. Serta kalau fragment adalah kode yang kita gunakan untuk mewarnai color the vertex that we are defined before. We are going to color it, and then we like the vertex shader, we are going to create shader here, create shader. The parameter is different. Here we use the fragment shader. Because this is a fragment, and then we are going to create the source, context, share show. There is parameter, shader, and fragment. This variable is used to define the vertex, the position, and the point size. And this fragment variable is used to define the color of the vertex that we are going to draw in our canvas. Both vertex and fragment shader need to be compiled by the system. We can use this shader source to attach this definition, and then compile shader to execute the definition here, the setting here, the position, the point size, or maybe the file shader. Now we have the vertex shader and fragment shader. We have defined the vertex and also the fragment. We have the position and size of vertex in the vertex shader, and in the fragment shader we have the color. Okay, let's continue. After we make a vertex and the color, its position, etc., after we draw it, to make this vertex can be shown in our canvas, we need to make a program, execution program, so computer can execute this program and then can give a response and make the GPU to show the definition, the vertex and fragment definition that we write here. Jadi setelah kita mendefinisikan vertex shader dan juga fragment shader, jadi vertex shader ini hubungannya dengan posisi dan ukuran dari titik itu tadi, sedangkan fragment hubungannya adalah dengan warna. Nah, selanjutnya kita akan membuat program ini bisa dieksekusi. We need to execute this program first. So, ya kan CPU itu kan dia akan merunning itu ya, merunning program files itu, mengeksekusi file exe-nya itu tadi. Dari instruksi situ dia akan melakukan pengaturan sesuai dengan apa yang sudah kita definisikan. Jadi we are going to create the program here, and then the CPU will execute the program, and then will respond as what is seperti yang sudah diinstruksikan di sini. Jadi akan memberikan respon sesuai dengan apa yang diinstruksikan di sini dan menyuruh GPU memberikan respon itu sesuai dengan apa yang diharapkan tadi. Misalnya untuk menggambar ini, jadi yang menggambar nanti GPU. Untuk menggambar titik, memberikan warna sampai akhirnya muncul di frame buffer and it can be shown in our web browser, something like that. Now, to create the program here, I'm going to define a new variable named shader program. Context, create shader, but create program. Yeah, shader program, context, create program. After that, I'm going to attach the shader and attach the fragment and the vertex into this program. Jadi kan ceritanya CPU itu kan mengeksekusi file.exe-nya. Nah, di file.exe itu ternyata ada attachment, ada perintah, ada instruksi yang CPU itu untuk mengirimkan data ini dan menyuruh GPU untuk menggambar sesuai dengan instruksi yang diberikan. Here I'm going to attach the configuration of the vertex and then the text dot. I'm going to attach the configuration, attach shader. Ya, GPU itu kan punya shader ya. Kalau kita baca di slide tadi, GPU itu terdiri dari GPU is controlled through programs called shaders. Jadi kita akan menggambar vertexnya, kita akan attach itu. Jadi kita akan jalankan dulu program exe-nya dari CPU. Nah, dari CPU itu nanti akhirnya dijalankan ada instruksi untuk JPU. JPU itu untuk memberikan respon berupa visualisasi gambar yang definisinya, yang gambarnya itu didefinisikan di program ini gitu ya, seperti shadernya. Nah di sini, jadi kita akan menambahkan shader. Di sini ada shader program, and then the parameter, the second parameter is the vertex shader. We are going to attach the vertex first. Kita akan menambahkan vertexnya terlebih dahulu. Lalu kita akan menambahkan ini juga pengaturan fragmentnya. The shader, ini juga sama, shader program. And then this is the fragment shader. Here, after this one, okay, what? Cannot. Sorry, we're not using TypeScript. We can JS variables autocomplete work. Okay, ya. Autocomplete ya. Oke, selanjutnya di sini ya, after we are going to link the program, link program, shader program, and then context, use program, shader, and then before we draw the definition here, before we draw in the canvas, we need to clear the canvas first. After we clear the canvas, we also need to add the background color of the canvas. Here we are going to make context, clear color, then this is the color of the canvas. Maybe I'm going to, ini satu ya, karena ini transparency. The last parameter is transparency. And then text clear, context color buff bit. Here we are to GL brown drag it draw array. That 0. Yeah, for the tip, if you are going to show the tips, or maybe tips, here we can use what clearance quick tip here. Yeah, okay, I think that's draw arrays GL. Yeah, this is all the code. Jadi kita definisikan dulu tempat kita untuk menggambar, media kita, kertasnya. We use this document get element by ID. We are going to get our paper to draw, and then the next we are define the tools that we are going to draw. Kita mendefinisikan toolsnya, perangkat yang akan kita gunakan untuk menggambar, seperti bolpen gitu ya, tinta, pensil dan sebagainya. Di sini kita menggunakan WebGL library, and then the next here we are going to define the first point, poin pertama, titik pertama yang akan kita gambar, that we are going to draw in our canvas. Yeah, to define it, we define a variable named vertex shader code. In this vertex shader code, we have GL position and GL point size. The GL position itself is a vector full dimension that have full parameter here. Yeah, the first parameter is the position X, Y, and Z, yeah, and this one is projection. This GL position use homogeneous coordinate. Jadi GL position ini menggunakan homogeneous coordinate yang terdiri dari 4 parameter. They have full parameter. The first is X, Y, and Z, and this one is projection. This coordinate, the position of the vertex is the result of the multiplication between the X position and the projection. Ya, jadi posisi koordinat dari vertex tadi, titik tadi adalah berdasarkan hasil perkalian multiplication result between ini projection dan X, projection dan Y, projection dan Z itu ya, itu posisinya. Selanjutnya, this is also GL point size parameter that is used to define the size of the vertex. Jadi ini untuk digunakan untuk mendefinisikan ukuran dari vertex. After that, we are going to create the shader by using this function. Ya, vertex shader, shader source, compile shader. After the shader is created, after the shader is created, we are going to define the fragment. Nah, fragment is used to color the vertex. Jadi fragment ini digunakan untuk mewarnai vertex tadi, gitu ya. As we know in this process ya, the first process is vertex processing. We need to collect the vertex. Di tahap pertama di sini adalah vertex processing. Kita butuh mengumpulkan vertex-vertex itu. Ya, ini ya vertex processing. And then this is the process to put the vertex based on its coordinate in the canvas ya. Jadi di tahap ini clipping and primitive assembly kita akan mencoba memposisikan vertex-vertex tadi sesuai dengan koordinat yang sudah didefinisikan dan size-nya juga. Setelah itu ada proses rasterization dan di tahap fragment processing ini kita akan memberikan warna. So we can define the color of our vertex by use this fragment shader code. Yeah, we use GL fragment color. There are 4 parameters here, 4 parameters. Ada green, red ya. Yang pertama ini adalah red, lalu ada green, ini ada blue, lalu one. Ini yang terakhir the fourth parameter describe the transparency. Jadi transparency. Jadi kalau kita mau buat dia agak sedikit transparan, nah kita bisa menggunakan this alpha parameter. Namanya alpha. Okay, like the vertex shader, we need to compile the shader. We need to create the shader first. We create the shader, we add this configuration that we define in this variable here, and then we compile it. Next, to make our untuk membuat gambar kita bisa ditampilkan, to make our graphic can be shown in our canvas, we need to make it as a program so CPU can compile it. Ya, when the CPU compile it and then not CPU jadi dia akan menjadi file.exe yang bisa di-compile. Selanjutnya file exe itu akan mengirimkan instruksi ke GPU. GPU itu akan membaca instruksi-instruksi yang ada di sini jika tidak salah. Jadi seperti misalnya apa saja yang ada, seperti attach shader, ada shadernya, kita akan membuat shader, vertex shader. Lalu juga ini ada shader yang ditambahkan, apa itu? Fragment shader. Jadi kan tadi kalau kita lihat GPU itu kan ada shader-shadernya ya. Nah, di situ shader-shader yang ada di GPU itu programnya ya, kalau kita lihat di sini ya. GPU is controlled through programs called shaders. Jadi program-program ini nanti yang akan membuat vertex dan juga fragment. Setelah itu kita link, kita use program. Nah, sebelum itu ditampilkan, before we show the configuration, before we show this configuration, we need to clear the color of the background of our canvas ya. We need to clear the canvas background color. So we need this code to define the color of the canvas. Ini untuk mendefinisikan warna kanvasnya, backgroundnya, lalu kita clear, setelah itu kita draw erase sesuai dengan konfigurasi di atas. Itu kurang lebihnya. Nah, this one, okay, I think there is some people here use program is not valid. Main.js line, okay, shader program in line, okay, 30. Let's see. The shader program, link program, shader program, and then shader program, use program, shader, shader, touch, shader program, context, create Wait a minute. Clear color. I'm going to change the color of the background here because I use. Okay, now it's become, but the color is the error is still, the warning is still, is use frame, draw a use frame. Oh, use program shader. The text with program text shader. Okay, maybe there is something wrong. For the code, for the shader. Okay, with compile program, with program attach. Okay, is there anyone can know what's wrong? Okay, let me check and troubleshoot this code. There is warning that my text cannot be shown in the browser here. I think it must be one text here. The color is red, like what I defined here. The red, blue, the points tan. Sometimes I forget to type. I type the wrong.
It's good that we have the error right now, Bu Siska.
Oh, okay.
When the warning say that
Invalid
it
operation.
is invalid operation, a program is not valid, something like that, it means that there is a problem with our shader program. So we
Yeah.
need to check inside the void main, both of the void mains. So there should be some errors there. And in your case, the error is, the mistake is in the flag color. It should be capital F.
Oh. Oh yeah. Okay. Red color. I apologize. Okay. The GL flag color is the part, the in the fragment code it defines the fragment color. The function should be typed with the capital F frag color. Yes. Okay. Like okay, yeah. Okay, thank you very much, Mr. Hazik, for the code. Yeah. Okay, something like that. Yeah.
Do you have any problem, guys, with the code? If you have any error on your console, you can turn on your stream so we can check
Yeah, we
and
can
help you.
if we are going to define this fragment color, the sign will disappear from us. It becomes transparent. But when we define this alpha parameter higher than 0, it will show the warna yang sedikit soft dari warna. For the example, if we type 1, this red become color.
Yeah. You said transparency and
Yeah.
alpha back then. But we need to remember that transparency is the inverse of alpha. So the value that you show us from the PowerPoint slides, the configuration to set the image transparency or color transparency in the PowerPoint, the
Yeah.
value is inverse.
Inverse,
So when we
berlawanan.
put 100% transparency in the PowerPoint, it means a zero alpha in
Yeah.
the graphics.
The graphics, yeah, that's right. Yeah, if we set the transparency in this PowerPoint as 100, it become transparent, and it's berlawanan dengan, dan dia berlawanan dengan yang di ya ada ini. If we define it 1 kan sama dengan 100% ya. The point will in.
Right. Okay, so again, we need to really understand the basics, the foundation of the computer graphics through these codes, through these lines of code. As Abu Siska mentioned, that the canvas that we define in the beginning of the code on the top of the line is basically the paper. Analogically, this is gonna be the paper that our computer will draw on. And the context will be the pointer to the tools that the computer will use. In a real life, when we draw something on the canvas, we may choose the media. We may choose the tools. We can use the water brush, or maybe we can use airbrush if we want to draw a mural, or we can use paintbrush, etc. So there are a bunch of options that you can use. In this case, the context will help us to opt or to choose, to pick what kind of tools that we would like to use for the drawing. And to build the tools, in this case, we will manufacture or we will create a shader program. Okay? And the shader program consists of vertex part and vertex operation and fragment operation. Vertex shader, fragment shader. The vertex will be responsible for the definition of our drawing structure. So where is the point location, where is the line location, or from which point to which point the line should be drawn. That's the responsibility of the vertex shader. And then fragment shader will be responsible for the color, for the fragments, for the looks of the pixels, the looks in the end on the screen. And this structure and this look should work together. And we will mix these two shaders as a single program. Okay. So we need to create kind of a package. You may say that on this package, we will put the vertex shader and we will put the fragment shader and mix them up through the link program, using the link program. Okay, so once you link the program, means that mixture is ready, the paints is ready already. Then to start asking the computer to hold the brushes, you should use program. Use program for it. So by typing or executing context.useProgram and then what is the program name, it means that you instruct the computer to hold the paintbrushes, and ready to draw. And on the next line, you start to ask the computer to fill the background with some color. By executing the clear color method or clear color function means that you ask the computer to pick the color from its palette. So for example, you have a package and there are many colors inside the package. By stating clear color, and then in this case is the white color, means that you ask the computer to white brush or white pencil color, white water brush, etc. Or maybe you can try to use another color, Busiska, and show
The clear
everybody
color.
that it matters.
The clear
For
color or the
example,
fragment.
the clear color.
Okay,
The clear color. So means that we want to change the background. So let's say
The-
this is RGB, red.
red.
Let's see.
Yeah. Yeah. The color
Total
is
red.
Yeah, the
And the
vertex
dot is also red, so we cannot
Yeah,
see
also
anything.
red.
Maybe we can
Yeah.
choose to mix red and blue to create, or maybe okay, green is okay.
Oh yeah, I'm so
Alright.
sorry. That's green.
So here we go. Okay. So the green, that's great.
Yeah.
And when we execute dot clear, that method, it means that we instruct the computer to start filling the background with that color. And on the draw arrays, basically we will ask the computer to draw something based on the structure that is defined previously on the top of the codes. In this case, for our today's hands-on, we draw only single point. But inshallah, next week we will try to draw more items with more primitives. And points is actually one of the primitives that we will learn in this course. There will be many others.
Yeah, maybe a student who play Tetris in Plaza Supano before this course begin can implement this code to create the Tetris game as their final project in this course. Yeah. Okay, is there any question, guys, before I continue to the next?
Yeah, we may go back to the slide then. It seems that no one asking a question.
Can I ask some?
Okay, yeah.
Oh, Gary,
okay.
go ahead.
Okay. Yeah.
I'm so confused about the draw array context points because I think I know. Does the dot that we draw have some kind of position that we can update?
Supposed to be. Yeah, supposed to be. And unfortunately, we have nothing to update for today. Usually, we will define the variable out of the shaders. So we should define it inside the JavaScript, and we do not have any vertex or vertices data now. And we define the location of the vertex, that single vertex, directly in the shader. Yeah, and
Okay, so
it is just, yeah, it's not dynamic then. It's static. You will the one that you expect to have will be in the next meeting, Gary.
okay, thank you.
Okay, if you search in the Google about this draw array function, you will find that this parameter in the draw arrays here is mode. Mode means the tools that you are going to use to draw in your canvas. Here we use the WebGL, and points means that we are going to draw a single point, and then 0 here means first, and then 1 means how many points that you are going to. Yeah, you can Google. Yeah, we can search for more explanation in the Google, but that's what I get. There is also there are so many type primitive, yeah, possible value. There's not only context point here. There's also line strip to draw a line, and then line loop to draw a loop, something like that. Triangle strip, and etc. to draw arrays here. We are going to learn it in the next meeting. Okay. If there is no any question, okay, this is documentation of the code. Okay, I'm
I
going
think you
to
should
upload.
install the extensions.
Oh yeah.
We have informed you about the 13 extensions that we suggest you to install.
WebGL syntax in.
Yes, that one. I suggest you to install that one. Maybe I need to cite this post. Check on this, Shafiq.
Okay. If there is no other question, I'm going to continue for the next section here. We are going to learn about the vertex processing, this object coordinate. From the code, we define the object of the coordinate of the vertex, and then the vertex will be put in the eye or camera coordinate, and we can see the object based on the batasan, based on the kamera koordinat. Jadi ada objek koordinat objek, tapi yang akan ditampilkan di screen coordinate, what will be shown in the screen coordinate is based on the A or camera coordinate. Jadi berdasarkan cakupan dari kamera itu tadi. Jadi for the example, if we have a triangle, here we have a triangle. Triangle has 3 vertex. 1, 2, 3. But ketika kita when we use the camera and make when we set the position of the camera, the angle of the camera, this triangle become like this. There is no tidak semua posisi, tidak semua bangun, tidak semua bagian dari segitiga ini nampak di kamera. This is what we call a clip out. Jadi tidak semuanya nampak di kamera, sehingga di sini tidak ada lagi 3 titik. There are 2 vertex here, 1, 2, 3, 4, and this figure that will be shown in the screen coordinate, that will be mapped in the screen coordinate based on what is captured by the camera. Jadi apa yang akan muncul di koordinat screen kita adalah berdasarkan apa yang ditangkap kamera, and it based on the angle, dan itu berdasarkan dari sudut pandangnya sampai di mana. Most of the work executed in the vertex processing pipeline is converting the object representation from one coordinate system to another. Any change in the coordinate is equivalent to matrix transformation. This related to the linear algebra. Yeah, when we are going to move this triangle, we not only move one vertex but also all vertex that in this triangle, ya. Jadi ketika kita ingin memindahkan segitiga ini, jadi kita akan tidak hanya memindahkan satu titik saja, semua titik yang menyusun segitiga ini, all the vertex here, and we can assume that the vertex here as a matrix. So when we are going to move these triangles, we need to use the matrix formation. Is there any thing that you confused about my question? If there is nothing, we are going to continue to the projection part of vertex processing. Yeah, projection is a process combining a three-dimensional object to produce a two-dimensional image. Like what I explained to all of you before in the previous meet last week, I said that computer has two-dimensional view ya. Jadi komputer itu hanya bisa menampilkan dua dimensi, two-dimensional view. To simulate the three-dimensional object, computer use projection. Ya, jadi untuk mensimulasikan tampilan tiga dimensional, objek tiga dimensi, komputer menggunakan projection, projection ya. In vertex processing, in the projection occurs when the object coordinates are converted to camera eye coordinates. Jadi dalam vertex di vertex processing ini, projection ini dilakukan adalah ketika objek koordinatnya itu dikonversi menjadi kamera atau eye coordinate. Jadi seperti segitiga tadi. Jadi proyeksi. Jadi ketika kita melihat apa yang kita lihat di mata adalah sesuai dengan batasan cakupan penglihatan kita. Not all of the object can be viewed in the scene because the camera can only capture based on the angle. Jadi di kamera itu hanya bisa mengcapture sesuai dengan angle-nya, sudut pandangnya itu tadi gitu ya. Tidak semuanya bisa di capture. There are two types of projection here, perspective projection. Yeah, all projectors meet at a central point of projection, and then there are also parallel projection. Projectors are parallel. The center of projection is replaced by the direction of projection. In this course, we are going to learn more about perspective projection. And then this is what I call clipping. Yeah. We see this object, this is a three-dimensional object in our real environment, but camera can only capture, the camera can only capture only side that can be captured. Ya, jadi kamera itu hanya bisa mengcapture bagian yang bisa ditangkap gitu ya. Capture ya seperti itu. Jadi seperti ini, if we see here, kamera can only capture the front of the object. It is because of the angle of view. Jadi tergantung dari angle-nya tadi, sudut pandangnya tadi. Jadi dia hanya bisa menampilkan yang di bagian depan. Ya, tergantung dari batasan cakupan dari kamera itu tadi. Nah, kalau misalnya kita mengganti when we change the angle of view. Nah, ketika kita mengganti angle of view-nya, tidak semua bagian dari objek tiga dimensi ini juga akan terlihat. Nah, bagian dari objek tiga dimensi yang tidak terlihat, ya, yang tidak cannot see in the whole scene, itu bisa disebut dengan clipping, clip out, gitu ya. Seperti itu. Jadi ketika ada objek tiga dimensi, tapi ketika kita pakai kamera, ketika kita lihat dengan mata, ada bagian yang tidak terlihat, yang tidak bisa terlihat. Itu tergantung dari sudut pandangnya, angle of view. Nah, itu bisa just like camera in the real world. Jadi seperti kamera di dunia nyata, cannot see the whole scene. Jadi tidak bisa melihat semua scene-nya, semua yang ada di sekitarnya gitu ya. Virtual camera can see only part of the scene. Jadi virtual kamera ini hanya bisa melihat bagian yang ada di scene itu saja from the object space. Object that are not in the view volume. Jadi istilahnya di sini nanti ada view volume ini ya, di bagian view volume ini. Di sini, di bagian view volume ini are considered to be clipped out the view, terpotong dari tampilan, gitu ya. Jadi ya, to change, bentar ya. As we see here, there is a 3D object, but our camera cannot see the whole scene of this 3D object. So it can only capture the side. The part that he can capture based on the angle of view. Jadi dia hanya bisa melihat bagian yang bisa dia lihat yang sesuai dengan cakupannya berdasarkan dengan angle of view-nya itu tadi. Like this picture, the objects that are not viewed in the view volume are considered to be clipped out. Jadi bagian dari gambar ini yang tidak muncul di tampilan layar itu tadi, itu bisa disebut dengan istilah clip out atau keluar dari gambar. Kurang lebih seperti itu. And then we continue to the primitive assembly. This primitive assembly, the vertex needs to be collected into geometric objects before the rasterization process. Basic geometry objects or what so-called primitive assembly include point. Jadi after we define the vertex, we need to put the vertex based on its coordinates, and then we are going to collect any basic geometry, such as point, line, polygon, or curve or surface, yang menyusun objek itu, and put it in their position in this primitive assembly. Seperti itu. And then the next step is rasterization. If an object is not clipped out, jadi ketika objek tadi tidak terpotong dari kamera, the corresponding pixel in the frame buffer must already be colored. Jadi seperti segitiga tadi, kita tadi gambar segitiga ya, awalnya segitiga have 3 vertex. Segitiga have 3 vertex, 3 titik itu tadi, but when the triangle is clipped out, it become 4 vertex. Ya, jadi ketika segitiganya tadi di clip out, itu jadi 4 vertex yang menyusun. And then we need to color the current 4 vertex. Jadi kita akan memberi warna 4 vertex sisanya yang itu tadi yang terpotong ya. Jadi ketika objek itu tidak terpotong, the corresponding pixel, jadi pixel-pixel yang menyusun segitiga tadi itu yang akan diwarnai. Tuh. The rasterizer produce a set of fragment. Jadi di dalam rasterization ini, they will memproduksi fragment untuk masing-masing objeknya. Fragments are potential pixel which has location. Jadi dia punya location in the frame buffer and also has a color and depth attributes. The vertex attributes are interpolated across object by the rasterizer. Yes. And then the fourth process is fragment processing. Like we had done before, we create a fragment shader to color the pixel, the vertex that we have defined before. The fragments that have been collected by the rasterizer are processed to determine the color of pixel associated with them in the frame buffer. The colors can be determined by texture mapping, interpolation of vertex color. A fragment may be covered by another fragment that is closer to the camera in depth. In this case, a hidden surface removal process needs to be carried out. The means of hidden surface removal, in the real world, when we put object, in front of the camera, there are so many objects in front of the camera. There is some object hidden. There are some object hidden. So the hidden object cannot be shown in the camera, because they are ketutupan karena mereka ketutupan dengan objek yang lain. Jadi ketika di dunia nyata, we put some objects, kita menyusun beberapa objek, kita meletakkan beberapa objek. The hidden object cannot be shown in the camera. Objek-objek yang tersembunyi itu tidak bisa nggak bisa ditampilkan di kamera karena ketutupan. Nah, di sini we are going to use hidden surface removal, to make sure this hidden surface berjalan dengan baik, running well. Okay, that's all the slide. Is there any question, or maybe is there anything else that to be?
Excuse me, ma'am.
Yeah.
Excuse me, Bu Siska.
Yeah.
May I ask you just one question?
Okay.
Today? Okay. We know will make impact for computer eye to analyze. Maybe I wanna ask about standardization, the computer eye and human eye. Maybe it's impossible to implementation, but I wanna ask you about your perception, maybe how to standardization computer eye and human eye to same perception. Maybe we know computer eye and human eye is very different.
Yeah, like all of us, like we know here that computer eye can be used by, we can use camera as the computer eye. Is that right? Yeah, we can use camera as the computer eye. And camera and human eye have a big difference. Camera has resolution, right? And then resolusi, ketajaman ya. Jadi ya resolusi ya. Camera has a resolution and our eye has great resolution if we compare it with the camera. In the computer graphics, seiring dengan berkembangnya teknologi komputer ini, awalnya for the first time we use a camera with the resolution is not high as high as today's technology. Jadi zaman dulu kameranya tidak setinggi sekarang resolusinya gitu ya. Ya, if we capture picture, there is a pixelization there. Jadi ketika kita dulu mengambil gambar itu ada pixelization yang didapat, jadi kayak blur tadi ya, ada titik-titik yang tidak jelas karena memang resolusinya masih rendah. Tapi seiring dengan berjalannya waktu, kamera, perkembangan teknologi juga semakin berkembang, the device-nya juga berkembang, device kamera jadi juga berkembang, perangkat kameranya itu meskipun tidak bisa menyamai dengan kekuatan mata manusia. Lalu bagaimana komputer mensimulasikan mata tersebut ya melalui kamera virtual ini? Jadi mereka mereka akhirnya mensimulasikan berdasarkan ini saja, sudut pandang seperti itu. Jadi like what I said before, like I had explained in this presentation, this projection and then clipping here is the process to simulate what human eye did ya. Ini untuk mensimulasikan apa yang dilakukan oleh mata manusia. Jadi projection, sudut pandang gitu ya. Bukan projection, sorry. Ya benar, projection ya. Jadi kalau misalnya kita lihat, kalau di sini kan kita melihatnya objek 3 dimensi, proyeksi 3 dimensi gitu ya. Koordinat mata manusia. Tapi sebenarnya kalau kita tahu di sini ada banyak hal in our surrounding gitu ya. Ada banyak objek gitu. Tapi yang kita lihat adalah, yang kita petakan adalah sesuai dengan apa yang kita lihat. Nah, that's why in orang-orang yang belajar kesenian, maybe I'm going to answer it in Indonesia, in bahasa, because my English is not as good as all of you here. Ya, mungkin di pelajaran kesenian kita juga bisa ada ketika kita ingin menggambar itu ada istilahnya perspektif ya. Perspektif. Nah, itu dari pandang yang beda. Jadi di sini, di mana itu di komputer, dia juga akan mencoba mensimulasikan hal tersebut dengan menggunakan bukan proyeksi ya, maksud saya perspektif gitu ya, perspektif gambar yang berbeda, gambar perspektif. Itu berdasarkan sudut pandangnya itu tadi. Jadi pendapat saya, maybe you still confused with my answer?
Okay, let me share my thought about this question. Before I explain how the computer eye works to be the same with the human eye, let me ask you a question, Fitra. Fitra, do you monitor?
Yes, sir.
All right, so let me ask you a question. How do you let the computer understand alphabet? A, B, C, D. How human being did that to let computers have the same understanding about the alphabet with us, the same with us as a human being.
Introduce the alphabet to the computer.
introduce the alphabet.
Yeah, like
Mm,
beginning
how do we introduce that? How did we introduce that so far?
by using a program.
Okay, using program. To be specific, more specifically, maybe. How do you think, Fitra? Do you have any idea? How
I'm sorry,
do
sir.
computer know
Um,
about the alphabet? Mhm. In
as
your opinion?
another course, sir. Um, I I have a web now.
Okay,
Oh,
okay. So, all right.
okay.
All
Kita
right,
lewat.
let me directly answer my own question then.
Okay.
We or maybe some of you may give your thoughts, opinions about question on the meeting chat. I will read it out later. So so do you know A A ASCII, right? ASCII,
Oh,
the
ASCII. Yeah,
alphabet
ASCII.
coding.
Yeah, ASCII
So
language.
you have you map the numbers with character,
Yeah.
something like that. So if you give computer number, then computer will give you the characters that you want. On yeah, I think Putra is are also correct when saying that through the electric circuit, but I think it's a very in a if we are talking about the low level computation, then we may refer to the electric circuit. But if we talk about on the higher level discussion in the more abstract, yeah, I think it's more abstract level. At least we know that computer understand the map of ASCII and numbers, the hexa codes maybe
That's a good ASCII number.
that is corresponded with that characters. So that is the standard, right, for understanding the same alphabets with the human being. The standards that the computer use to understand the same thing with the human being, with us. Now, how do we standardize the understanding of how to draw something between computers and us? If we, yeah, I agree with Fitra. If we do not have this kind of standard, then it's impossible for us to communicate with computer, to ask them, to ask it to do the drawing. The answer will be on the next meetings. So basically, the shader, the one that we define inside the shader program, that is the standard mechanism that we can understand and computer can understand to achieve the same goals, drawing something and display it on the monitor, for example. Okay. And if we talk about what is happened in the background upon this standardization, it's basically some computer graphics algorithm. And those algorithms are the things that we will learn in this course. Okay. One of them will be about the perspective, the projection that Bu Siska has has told us lately. So, for example, to let computers understand how to draw something based on the data that it receives, then the computer need to execute some formula, some step-by-step algorithm. And that is actually the thing that we always do in informatics, right? As a student of informatics, we always try to transform the data that can be understood by the computer into something that can be understood by humans. So that's the informatics engineer do all the time. So you transform the data that is understood by the computer into information which is understood by human being. And specifically in our course, we will learn how to transform the three-dimensional data that is understood by the computer into a visual things that can be seen, that can be perceived by the human being. And the process between the data and this information is the standard procedure that you may refer to, Fitra. Hope that answers your question. All right, everybody's hungry already. So maybe
Yeah.
we can wrap up the meeting because I think it's all quite over time.
Yeah.
Bu Siska, yeah.
Okay. Thank you very much, guys, for the response, for the attention, and then thank you for the question. Yeah. Thank you for anything that you had make that make this class today to become a great. Terima kasih banyak ya karena sudah membuat kelas ini ramai hari ini. Okay, thank you for the participation, thank you for the attendance, thank you for the question also. Maybe maybe we can end our meeting today. And I apologize for any mistakes because for me I prefer writing in English than speaking in English because for me it's difficult to speak in English because my pronunciation is not good and then I need okay.
No worry, Bu. we together we learn. Yeah.
Okay, thank you very much. I'm going to end this meeting. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore, good afternoon, everybody. Okay.
Thank you very much.
Okay. Thank you very much.
Thank you.